Good morning to all of you. So let's start today's session. So as you remember, we're doing CCNA-1 Introduction to Networks. And thus far, we have covered 8 topics. And today we'll be doing topic number 9, which is address resolution. Okay. Address resolution, what does that mean? It's sort of a mapping between your IP addresses, both IP version 4 and IP version 6, to the MAC address, the hardware address of your NIC. That's it. That's what address resolution is all about. Okay. So we'll be looking at MAC and IP address, both for IP version 4 and IP version 6. We will see the roles of MAC address and IP address. And then we will look at address resolution protocol. Okay. Why do we need ARP? Very simple. We need ARP because of IP version 4 addresses. Why do we need ND? Again, we need ND because of IP version 6 addresses. Okay. So today's lesson is actually very straightforward and short. So as we know, there are 2 addresses in play in every network. One is your hardware address, which is your MAC address, layer 2 address. Remember layer 2, data link layer. And the other one is an IP address, layer 3 address, network address. Okay. So there is a table in every machine that tells what is the IP address of the neighboring devices and their corresponding MAC address. Okay. And if a new device is added to the network, then it will update that table to get the new device's MAC address. Okay, so the table which maps the IP address to the MAC address, okay, that one is your ARP table as far as your IP version 4 is concerned. Okay, in IP version 6, it's something else. We call it ND, neighbor discovery. Okay, now, as you know, in an Ethernet LAN, every device that has got a network interface card, any device, be it a computer to a server to a printer to a IoT device, any device, it has got a MAC address associated with it. That one is your layer 2, okay, data link layer, MAC address. So as long as you're on the same network, these MAC addresses can communicate with each other, okay, as long as you're on the same network. The moment you want to go outside the network, the MAC address can only go until the gateway. That means the router. So the MAC, the destination is going to be the MAC of the router, because outside that router, outside the network, then the IP version 4 or IP version 6 address will take place, will be in inactive mode. Okay. So layer 2 physical address, the MAC address. Okay, that's what we have in every device. Okay, and we also have an IP address. IP address is layer 3, network layer. a logical address. Okay, it can be IP version 4 or IP version 6. And that is responsible for sending a packet from a source to a destination device. Okay. Now look here. I have got a device. Look at the IP address 4/24. That means, okay, let me just, that means over here, the first 3 octets are for network. /24 means 255.255.255.0. This is for the host. Okay, so that means all these devices there, you can see it's the same thing. Okay, you see the network portion is the same. There, this is the network address 192.168.10.0. This tells you that the host portion is only 8 bits. Okay, so how many devices do we have over here? We have got a switch, we have got a PC1, we've got a PC2. Okay, and then the IP address for PC1 is 10, for PC2 is 11. Okay, now that being said, these devices have got a MAC address associated with them. So PC1 has got this MAC address and PC2 has got this MAC address. Okay, very straightforward. So when you're sending your frames from PC1 to PC2, okay, so what PC1 will look at is at the ARP table, and it will find what is the destination MAC address. Okay, and then it will send the data to that MAC address within the same Ethernet network. Okay, within the same Ethernet network. Now, if it cannot find, if let's say I add a new device to the network, okay, let's say a new computer is added to the network, and let's say this one will have the address of 192.168, please forgive my mouse handwriting, 192.168.10, that's the network address, .13. Okay, this is a new device I've added. I connected to the switch. Okay, so what happens is the ARP table of PC1 perhaps is not updated yet. So what happens is PC1 will send a new ARP request. Okay, it will know, for example, I'm looking for 192.168.10.13. Can you please find this and tell me what is its MAC address? So it will send the ARP request, and that MAC address of PC, let's say 3, will be sent to the table of PC1. So next time PC1 wants to send a frame to PC3, it will just use the MAC destination address. Get it? Okay. So what you can do actually, every PC has got a table. It has got this ARP table. Okay. You can actually go and run the command. You see, you can just go, you can do it right now itself. Okay, just go and run this command, ARP, okay, /R. Press enter. I don't want to run it right now because I don't want you all to see my I don't want you all to see my MAC address on my devices that I have over here. Okay, but you can run on your own computer. Open it and run, and it will show you your PC's ARP table. Okay, that means IP version 4 IP addresses with a corresponding MAC addresses. It's amazing. Amazing command. Okay. Okay, now let's delete this. Okay, let's move on. You can try on your own device. Okay. On the other hand, if you are sending, okay, if an IP address is on a remote network, okay, let's say this is one network. Network address is 24 bits and host is 8 bits. This one, network address is 30 bits and host is 2 bits. Okay, so remember, that means over here, what would be the subnet mask for this? It would be 1, 1, 1, 1, 1, 1, 1, 1. Okay, dot, let's start here. 1, 1, 1, 1, 1, 1, 1, 1. So it would be 255 dot 255 dot 1, 1, 1, 1, 1, 1, 1, 1 dot 255. Okay, remember in network notation, you can either do it like this or you can do it like this. Dot 30 bits, right? So this is 24 if you count 24, 25, 26, 27, 28, 29, 30. And the others is the host bit. So the host bit is only 2. Okay, because 32 minus 30, that means this is host bits. So host bits is only 2. So how many computers you can add? We have done this before. 2 to the power of 2 minus 2. Okay, so 4 minus 2 is equal to 2. So only 2 devices you can add. Okay, so the first, this is the network address, 209.165.200.224. Okay, so the first device will be .225. The second device is .227. The broadcast address is, sorry, .226 is the second device. The broadcast address is 227. Okay, so this is something I keep repeating so that we really become good. So this is 255.255.255. What would be the last one? Can you just change this? Someone please quickly change this into decimal form. Anyone? Anyone who is, yes, 2, yes. It's Cassandra and Heining. Okay, 252, yeah, well done. Okay, so in your exams, in your skill-based exams or other exams, we may give you your notation in this way, or we will give you in this way. Either way, you should know what it means. Okay, so remember the network portion is all the ones. Okay, /30. So you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That's what it means. Network bits is 30. Host bits is the zeros, 2. That means only 2 devices can be it. How do I know? Because 2 to the power of 2 minus 2 is equal to 2. Only 2 devices can be connected. And you see in this network, only R1's gigabit Ethernet 1 is connected to R2's gigabit Ethernet 1. That's it. So this is one network between 2 routers. Okay. So now coming back to what we were discussing, Okay, that was what we are. Every week, if you notice, I'm doing an IP address session, specifically IP version 4. I keep on repeating because this is important. And I'm doing this before we actually study IP version 4. We go into details of IP version 4 before you start your calculations and all that. The reason I'm doing this because I'm trying to set the uh, foundation for all of you so that when you arrive at that amazing location, which is IP version 4, you have got some foundation and you can understand better how to do IP version 4 addressing, how to do subnetting, and so on. Okay, because if there's anything challenging in this CCNA1, it is that topic perhaps. Okay, and that is something that is going to be repeated in CCNA2 and CCNA3. So that's the foundation which you cannot live with. I mean, that's very important. Your skill-based exam, the first thing you have to do is do the calculation and find out what IP addresses you have to give. If that one itself you cannot do, then what you want to do, I mean, you're failed. That's it. So that's the most important foundation. Okay. So now moving on, what happens if we know that if you are sending within the same network, okay, within the same network means within the confines of the exit device, which is your router. So this is one network. This is one network. This is one network. Okay. So we know that as long as each device has got a ARP table, we're talking about IP version 4 now. As long as each device has got an ARP table, the device, if it's going to another destination device within the network, it will just find the MAC and send it immediately, MAC address. On the other hand, if you are trying to send it, you see here the source is 10, which is this, and the destination is another network, which is this. Okay, so you're sending from here all the way to another network here. Okay, going through perhaps 2 hops. Now, how are you going to do that? What is the how will the MAC handle this? The MAC, as far as the MAC address is concerned, when you're going out of the network, the destination will always be the gateway address. Okay. So if this PC is going to send it to somewhere outside the network, it will look for the only device that is outside over here would be the gateway. Okay, which is not actually outside. This gateway is part of this network. You see, an IP address is given to it. Usually, .1 is always given. Usually, it's just an example. It's not a must. We can change that. Okay. So usually, .1 is given to the router interface, the gateway. Okay. And here, the ARP table of this, if anything that goes out, the distant gateway MAC address will be stored inside PC1. That's what will be stored in the ARP table. Okay. Now for IP version 6, it uses ICMP version 6 to associate the IP version 6 addresses of a device with a MAC address of the device NIC. And how does it do that? It uses something known as network discovery, ND. Now let's look at ARP a little bit more. So a device can use ARP to determine the destination MAC address of a local device. Okay. Each of these devices have got a table associated with them. Okay, for example, over here, .5 has got a table which has got the IP address of every computer, every device on the network, along with its MAC address. Okay. IP to MAC mapping. Okay. And that is the whole purpose of your ARP table. So ARP provides two basic functions. What are these two basic functions? Resolving IP version 4 addresses to MAC addresses. Yes, that is the first function. And maintaining an ARP table of IP version 4 to MAC address mappings. Why? So that next time you want to send a packet to any of these devices, what you can do is you can just look at the MAC address and directly send it. Okay. So every one of these have got, even the switch has got a table associating each of these devices. Okay. So every time you want to send, okay, you want to send a frame, what you will do is you will look at your ARP table. You will look at the IP version 4 and its corresponding MAC address. If you have found it, then you send it to that MAC address. If you haven't found it, then you send something known as ARP request. Okay, like this. You see, I need to send information to 192.168.1.7. This is all within the same network. So it's talking about this. But it does not have its MAC address. I don't know the MAC address of the device of 192.168.1.7. Okay, so you send an ARP request. And once you get the ARP request, what it does is it sends its MAC address to the requesting device. Okay. If you're trying to send outside the network, then the ARP table will only have one entry, and that is your gateway, the router where you're sending the data through. Okay. So if this is connected to a router, so this address over here, okay, will be stored as the outgoing MAC address. Okay. Did I miss a slide? No, we haven't come to that yet. Yeah, this is the one. Okay. Uh, a network is something which is lively and keeps changing. Okay, a network has to be scalable. Scalability is one of the features of a network. It means you can add devices, you can remove devices. So that is why the ARP table itself has to be always updated. The entries of your ARP table, where your IP version 4 mapping to the MAC address needs to be always updated. That table with its information, ARP cache information, comes with a expiry timer. Okay. You can also remove the ARP manually by giving certain commands. Okay. So over here, for example, PCA's ARP table uh, for the, okay, let's say you change your media interface, okay, and this is your IP address. So the PCA's ARP cache will also be updated. Every PC's ARP cache will be updated, okay? So this is within the same network. You can see the IP addresses. Okay, it's /24 slash 24 slash 24. So they are all within the same network. Okay. So is your gigabit Ethernet 00 interface over here. Okay. It is within the same network. This is actually important because knowing the MAC address can be a security risk, my dear students. Okay, that's why there are a lot of concerns about this. Okay, and that's why you see I did not run this command on my PC. Okay, ARP/A I did not run on my PC. I made a mistake. I put /R /A. Okay, it gives you your ARP table. Okay, try it out on your computer. Okay, right now, ARP/A, it gives you your internet address and its corresponding physical address of all the components on your network. Okay, you will get quite a few, whichever computers have communicated with your computer. You will get a list of all of them along with the MAC address. Try it out. You can see what I'm talking about. In the router itself also, you can say show IP ARP. Okay, and then it tells you what is your ARP address and the corresponding MAC address. Okay, so these are actually very powerful commands. Why they are powerful is because MAC addresses can be spoofed. Okay, you can use third-party software to actually spoof a MAC address. You can type the MAC address, and then your device will appear to be your gateway, if for example. So every device on the network will think that you are the gateway. Okay. So what you can do is you can spoof, okay, you can spoof your MAC address. You can change this MAC address by using software and make your MAC address into this one. Okay. So all the devices in the network will think that you are the gateway. So they will send their frames to you. Okay. So especially the outgoing ones, and then you can take those frames and uh, de-encapsulate them and see what is inside them. Okay. So that's why security issues, are very important when it comes to knowing the MAC address of your device. Okay. Um, no, the MAC address, is one of the ways people can even track you. Okay. Um, most of your devices, even if you take out your SIM card, people can still track you because of your MAC. That's why you see the the best way you can get rid of people tracking you is even your smartphone. Find out which section of that chip, of the motherboard chip, is uh, holding your MAC address, okay, your NIC, and destroy it. Okay, once you destroy it, that's it. You cannot be tracked. Okay, so it's all dependent on your this MAC address. That's why you have to be very careful with advertising your MAC address. Okay, that is why even today's lab exercise, do not play around with your I mean, you can have a look at it, but do not share it with others. What is the MAC addresses of your devices? Okay. So another issue you should know that if a device is doing an ARP request and every device is doing an ARP request, that can cause the network to, become a bit slower. Okay. Uh, so that could be an issue as well. Okay. And another thing is that uh, many of our latest switches, okay, they have got some security to protect from ARP attacks, from spoofing. Okay, it is very easy to, do some spoof attacks. You can try these experiments at home. You can go and get information from the internet. Okay, in the spirit of being a network engineer, one of the tasks that you are going to do is protect your network. So to protect your network, sometimes you have to be proactive and find out loopholes in your network. How do you do that? You try and attack your own network, okay? And see what are the loopholes in the network and how do you fix it. So you attack your own network before somebody else does it, okay? So that is something that as a network engineer, you can play around with, okay? Get a third-party software, spoof the the MAC address of perhaps your gateway or other uh, critical computers or devices in your network, and play around with it and see what you can do and how can you uh, deny spoofing, what software you can use to ensure that this does not happen. Okay. Yes, yes. Very good question. Virtual machines create a simulated address, MAC address, okay? Sort of a simulated MAC address just for the simulation to continue. But they all will be resting on the actual MAC address of your machine. But in order to have two operating systems communicate with each other, so they would be perhaps doing a simulation of that. Depends which virtual machine you're using. Okay. Now, if you have got your ARP for IP version 4, you also have got a neighbor discovery for IP version 6. So let's have a look at that. IP version 6 neighbor discovery ND protocol provides address resolution, router discovery, redirection services. Okay. So the idea is what it does, it sends a ping, ICMP uh, neighbor solicitation. If you're using IP version 6 address and you want to find out the other devices in your network, what it does is it sends a NS, okay? And also it sends a NA, neighbor advertisement. Okay, neighbor solicitation as in I'm looking for your MAC address, and neighbor advertisement as in this is my MAC address. Okay, if you're using IP version 6, okay, on your routers, then ICMTP version 6 router solicitation and router advertisement. This is for routers. These messages are used for messaging between devices and routers for router discovery. So using that between even routers, if you want to go from one router to another router, if you're using IP version 6 address, so IC MP version 6 redirect messages are used by routers for better next hop selections, for going from one machine to another machine. as far as your intermediary devices are concerned. I'm talking about routers. So an example is given over here. Okay. Look, we are within the same network. Okay. So PC1 will send a neighbor solicitation message. Hey, whoever has this IP version 6 address, send me your MAC address. So there it is. 11 is here. Now PC2 will say that, hi, 10, I am 11, and my MAC address is this. Okay, so in an Ethernet network, these devices will communicate with each other. Now, inside PC1, you have a table which shows the IP version 6 address, okay, mapping to the network interface hardware address, MAC address, okay. So that brings us to the end of today's session. Just remember, for IP version 4, we use ARP. For IP version 6, we use ND, Neighbor Discovery. Okay. Now, for today's lab, you'll be running versions of the command. So today's lab consists of two main exercises, where we start with 7.2.7, view network device MAC addresses. Okay. So do this topology and just go through the exercise. Okay. And, try out all these commands. Okay. So what you need to do is find out the MAC on your packet tracer, okay, by adding all these devices. I think somewhere here you can even, you see, running the command show up on your switch, okay. Show the MAC address table on your switch. Okay, so please do this right now. Do this topology. And once you're done with this, then you go to the next one, which is 7.3.7. Okay, view the switch MAC address table. Then you create this topology, follow this IP address. This is for your network. And then just go through the instructions. Please do both of these labs, that is, please do 7.2.7 and 7.3.7 in the same packet tracer. So on the left-hand side, you can do this. And then on the right-hand side of the packet tracer, you do this. And once you're done, just show it to me. And then I'll ask you a question based on the left-hand side or the right-hand side. Okay. I will ask you to run all these commands. So if I ask you to show me, for example, your ARP table of your PC, you'll be actually showing me the ARP table of the packet tracer PC. Okay, not your own ARP table. Okay, so in that way, we will be secure. So get started on this, my dear students, and once you're done, let me know. Okay. Before we continue, before we go to the lab exercise, sorry, do you have any questions with respect to ARP today, what we studied? Any questions? Okay, if not, then please get started.